Hey everyone, before I get into the content for this video, I wanted to remind everyone that the type of videos that I make, the type of content that I'll be putting out there is largely influenced by how people interact with the channel. If people watch a video and then they subscribe to the channel, or even while within the video, like let's take a look at this one here, if they subscribe from the playlist, if they're watching the video and they subscribe down here or they subscribe up here, those are all analytics that I'd be able to see. So whatever type of content that you enjoy, that you see valuable, that you want more of, then please be sure to go ahead and interact with the channel via subscriptions, clicking like on the videos, commenting in the videos, letting me know what type of content you want me to make more of. And with all that said, now I'll go ahead and jump into the actual point of the video here that you came to watch. In the last video that I did for CallManager traces, I went through two phones registered to the same server, and in this one I'll do two phones but registered to two different servers. It will still be in the same CUCM cluster, but it will be two different servers. So I'll draw up a topology real quick and I'll show you what the call flow will look like. Here's the call flow that I was talking about. It's going to be phone A calling phone B, and it's a SIP phone, so we'll have a SIP invite that comes into node 1, and then there will be SDL signaling that sends the call over to node 2 because phone B is registered with the other node. And then there will be a SIP invite that goes out to phone B, and then the SIP signaling will go through, and eventually the phone call will be connected, and these two will be able to talk to each other. So I want to talk a little bit more about SDL signaling. That's how the different applications on a single server talk to each other. So CLManager and CallManager services, those applications, the application CLManager and the application CallManager, they talk to each other with SDL signaling. Same thing with the application TFTP talks to other applications, which we call them services. But the services, when you look in CallManager traces, they call them applications, right? So those different applications, those different services talk to each other using SDL signaling. Now, when we talk between clusters, again, it uses SDL signaling. So when the CallManager service on node 1 wants to talk to the CallManager service on node 2, it uses SDL signaling. And then also database replication between the different nodes uses SDL signaling. So that's what this will look like. We have the timestamp for the call. We have the calling number. Annie is something that's used to annotate the calling number, and DNIS is also for the called number. These actually stand for something. I don't remember what they mean. I think like automatic number identification or something like that. And I don't know. I'd have to go look it up, but I know that the Annie is the calling number and the DNIS is the called number. So now that we have this information, we can go ahead and start analyzing the phone call. So just like with the previous phone call, the first thing I'm going to do is hit Control-Shift-F. I'm going to take the directory here. I'm going to copy that out, and I'm going to paste it in right here. You can see that I already had it in there, but I'm just doing this so people can see it. And we're going to look for the dialed digits just like we did before. We're going to put in DD, short for dialed digits, and then we're going to put in equals, and we're going to quote it. 2, 1, 2, 3. All right. And now we'll hit find all. We get the one hit because this was the only phone call at that time. I'll go here. And now I want to start marking this up. 1, 2, 3, 4, 5. Full DA. All right. And then I'll put in here so that I can see the calling number and the called number. I'll put that there as well. Now I'll scroll down and we see the dmpid request. This is the digit analysis process reaching out to the device manager process to find out the PID for the device. So that's going to be the dmpid, device manager PID. So we have the dmpid request, and then eventually the device manager replies to digit analysis and says, here's your dmpid. using the dmpid response. And then the next line here is what we really are coming for. And we'll do 1, 2, 3, 4, 5. And at the end of this line is the information that I want. All right, so we have, it's going to line control. That lets us know that it's staying in the cluster because it's going to a directory number. If you see line control, that means that it's going to a directory number on the cluster. And now I'll go ahead and highlight this first CI, and I'll highlight the CDCC as well. Right. And we'll just do a quick search for the first CI. And since I'm going to be repeating a lot of the same stuff that I did in my first video, I'm going to go through it a little bit faster. All right, so with the first CI, I scroll down until I see a break in the sequence, right? And then here it is, right? So we have this line, some numbers with a colon, and then some more numbers, and then a timestamp. And this, I look until I see a break in that sequence, and right here is the break. And that's my 180 ringing. It's going to be for party A. So I'll go ahead and highlight that with style token 1, and then I'll do Control-Shift-F, and I'll find the invite. So now I'm going to mark the invite. So this invite is inbound. We can see that it's incoming, and that's, you know, from the perspective of the CUCM. CUCM is receiving a message from the phone. All right, and that's coming from phone A. Since I'm here, I'll go ahead and mark up the other lines. So we get the invite, 100 trying, 180 ringing, 200 OK. So I want to mark that up because I know there's going to be SDP in there, which is the session description protocol. So outbound 200 OK. I'm just missing that. Sent to phone A. All right, and then let's see what's going on here. We get the ACK from phone A to CUCM, and then here we see a buy, and it's outgoing. That lets us know that the other side hung up, because what happens is phone B hangs up and CUCM receives that buy, then CUCM takes that buy and sends it out to phone A, so we see that it's outgoing. That lets me know that the other side hung up. 1, 2, 3, 4, 5, outbound. Buy to phone A. All right, save that. Now let's go back to the CI search up here, and I'll go to where CIA is associated with CIB, or you can say CI1 associated with CI2, however you want to call it. All right, so we take CI1 and 2, and I'll paste that in here. I'll highlight this now, style token 2. All right, so now we have the first CI and the second CI. And like we talked about in the previous video, these CIs are going to be call leg specific. All right, so let me mark this out. I'll paste in that CI here. So this CI goes to this leg, and then I'll take this and I'll put it on here. This CI, this other CI 6.7 is going to go to this call leg right there. So that CI is for phone A talking to the CUCM and CUCM talking to phone A. This CI is for CUCM talking to phone B and phone B talking to CUCM. So leg 1, leg 2. Now I'll go ahead and I'll search on this second CI. And I'll scroll down a bit. This is still stuff that we saw in the previous video. Right now I'm looking for that break in the, in the format here, the very rigid structure. I'm looking for the break in that structure. Let's see. All right, so we get one here. Let's see if this is the invite. This is the outgoing invite to phone B. Now there's something I want to point out here. If we were to look at this invite, we would see that there's no SDP. But the invite from the phone earlier did have SDP. So somewhere in the mix, CUCM took that SDP out and is saving it for later, right? So here we have an early offer invite. Here we have a delayed offer invite, meaning that there's no SDP. We'll send it later, okay? And then also there's something else that we can notice here. This file is SDL001. This file name starts with SDL002. That lets us know that there's two different servers here handling this call, all right? Which is expected. Also, if we looked at the directory path, you can see that this server's name is CUCM-115. This one is named CUCM-sub1. So again, indication that there's two different nodes handling the same phone call, all right? So let's go back to this outbound invite, and we're going to highlight with style token 2 this SIP call ID, and I'm going to go ahead and take a search on that, and we'll see 100 trying, 180 ringing, right? And then we get the 200 okay. I'll mark this up again because that's going to have SDP from the phone. So this lets me know that phone B has now gone off hook and has answered the phone call. And here they send us their SDP. So this is the SDP that comes with the phone B, right? We can see that phone B's IP address is right here, and I'll do style token 2. You can see right here it tells us I want to receive media at this IP address. And then if you look up here for the audio line, the M line for audio, they're also telling us their port, right? So we can see that the audio for phone 2 is going to be sent on this port, right? When you want to talk to phone 2, you need to be reaching out to this port at this IP address, all right? Now let's take a look at this ACK. We can see it's an outbound ACK. So outbound ACK to phone B, all right? Here is the SDP that was consumed by CallManager earlier, right? We had an early offer invite that came in and a delayed offer invite that went out. So we never sent phone B the SDP from phone A. But here in the ACK, after we receive a 200 OK from phone B, we send an ACK with the SDP that is associated with phone A, right? And this is going to be the IP address for phone A. And if we look at the M line for audio, this is going to be the port at which phone A is expecting to receive media. And here we can see the list has been truncated, right? It's a lot shorter than what was seen earlier. It's only sending codec 114. So that means that CallManager decided this is the codec that you two would agree upon based on your preference list. And we can see that that's Opus codec. And then down here, we receive a buy from phone B. 1, 2, 3, 1, 2, 3, 4, 5, inbound buy from phone B. And let's take a look at this at a high level. We get the inbound invite, and let's see how many codecs that sent. Look at all these codecs that it sent over, with Opus being the highest precedence, 114. But there's G722, ISAC, AMR, WB. So there's plenty of good stuff in there that got stripped out later, and they agreed upon on 114. We get the full digit analysis. We find the device PID. We associate CI1 with CI2. We send out a 200 OK to the phone at phone A. However, that 200 OK, if you look at it, happened at 15:58:21:464. 15:58:21:440. So we have to wait until we get the inbound 200 OK from phone B before it was sent to phone A. The reason why it's out of order up here, or it seems to be out of order, is because it's two different servers that are handling the call. Now, let's go back and take another look at this CI. We can search on CI1 or CI2. It doesn't matter for this particular thing that I'm looking to find. We're going to find all. And what I'm looking for is this CC setup request that's going outbound. And I've already found it right here. Let's go back to the front. This is the one of the main things I wanted to point out that's different between, you know, when a phone call is handled by a single server versus a phone call that's handled by more than one server, more than one CallManager server. Here's the SDL signal that I talked about. Earlier on, I talked about SDL. This SDL signal has a -O on it. That means that it's an outbound signal, and that tells me that it's CDCC reaching out to line control, and that's CDCC on node 1 reaching out to line control on node 2. And just looking at these processes, we can tell that, right? Because this first number right here, that's going to tell us what the node ID is, right? So this is node 1 is reaching out to node 2. And sometimes these numbers can be off, right? So if I were to rebuild node 2, it would come up with a higher number here. So don't really always rely on these numbers. Just understand that if like these numbers are node specific, because this could be node, in my mind, when I describe my cluster, I could say this is node 2, this is subscriber 1 or subscriber 2. But this number might be 17 because I've rebuilt that node a couple times, or I have a really big cluster and I rebuilt the node once. So I know that sounds a bit confusing. Just simply understand that the first number here lets you know the server, right? So right here, for example, SIP station CDFC is talking to SIP-D, but it's staying within the same server because they have that same first number. And so CDCC is sending a CC setup request to line control on a different node. Right, so what I would do here is I would just copy this out because that lets me know it's an outbound CC setup request. And then I would copy this out too, just so I can see what processes are talking and on which nodes. All right, now we should see this CC setup request come inbound on the other node, right? So we should see a -I on the other node. And let me just search on this particular process ID right here. So now you can see I have 58 hits, which is far less than 229 hits. So I can see right here is the outbound setup request. I'll minimize this, so I'm only looking at my other node. And right here you can see SDL-I. That lets me know that this is CC setup request coming inbound on my other server. So I'll just highlight this the same as I did before. And this is line control talking, or sorry, this is CDCC talking to line control. All right, so that should be about it that I was going to cover in this particular video. We talked about how the file name has a 1 or a 2 in front of it, or, you know, depending on whatever the node is, like it'll change even here with this. So if I were to reinstall this node, it would have a higher node number and it would say SDL002 or whatever the node number is. So that file name lets us know if it's on the same server or not. This number here lets us know if it's going on the same server or not. And then also the other thing is when we see messages going in and out on different nodes, that lets us know as well if the call is traversing over to a different server. And if we take a look at this at a higher level, you can see here that after getting the PID, it sent out the setup message to the other server. Over here, they received that setup message and then they reached out to the phone. So that's how this gets a little bit more complicated compared to looking at 2 phones registered to the same server versus 2 phones registered to different servers. I hope you like watching this, and for more content down the road, go ahead and subscribe. And I'll be doing some more complex phone calls as well in the traces where I start talking about phones being put on hold, phones being transferred, transcoders getting pulled in, conferences, music on hold resources, enunciators, all that different stuff. And then I'll even probably down the road talk about call failure scenarios. I'll probably make some calls fail and we'll troubleshoot to see why did the call fail. Again, thank you for watching, and I look forward to making some more of this content down the road.